Hello, good morning. Video 82, Lecture 20. It is for BSc Part 1, Organic Chemistry, Paper 2. In continuation of method of formation of alkenes, today we will see the third method, that is dehalogenation of vicinal dihalides. Dibromoethane, when reacted with zinc in presence of alcohol, it will form ethene and zinc bromide. Unsymmetrical 1,2-dibromopropane, when heated with zinc dust in presence of alcohol, it will form propene. This method is not useful for preparation of alkenes since the dihalide needed for the purpose are themselves prepared from alkenes by the addition of halogens. However, it is useful for the purification and protection of carbon-carbon double bond. Mechanism, zinc, it will give its electron and it will eliminate, it is a transition state, E2 mechanism, and it will form propene and ZnBr2. Physical properties of alkenes. State, smell, and color. C1 to C4 are in gaseous. Ethene has pleasant smell. C5 to C17 is liquid. C18 onwards solid. Only ethene has pleasant smell, while other alkenes have no smell. Solubility. Alkenes are also usually non-polar or weakly polar, insoluble in water and other polar solvents, while soluble in non-polar solvents such as benzene, carbon tetrachloride, petroleum ether, weakly polar solvents like ether. So this is weakly polar solvent. Density is slightly higher than the alkane and lower than water. Their molecular mass, it increases with the molecular mass and range is up to 0.98 grams centimeter cube. Boiling point increases with molecular mass. Boiling point is also increases. Branch chain alkenes have a lower boiling point compared to straight chain alkenes because the surface area is increasing. So van der Waals forces of attraction is also increasing. So branch chain having lower compared to straight chain. If we will compare cis and trans, cis isomer have dipole moment. They are polar and weak dipole. That trans having weak dipole moment interaction. So cis having higher boiling point compared to trans isomers. Melting point. Melting point of alkenes are higher than those of the corresponding alkanes. This is because electrons of a double bond are more polarizable than sigma electrons of single bonds. As a result, intermolecular forces of attraction are stronger in alkenes than in alkanes, and hence alkenes have higher melting point than the corresponding alkanes. See here, this is a cis 2-butene. Its melting point is about minus 139 degrees centigrade. It is lower compared to this trans 2-butene having higher 106 degrees centigrade. Minus, it is in minus. This is due to trans alkene being symmetrically packed more closely in the crystal lattice than the cis alkene molecules, which are less symmetrical. Dipole moment. Dipole moment is also this cis having higher than trans having zero, almost zero, trans 2 butene, trans 2 pentene having slightly greater dipole moment. Relative stabilities of alkenes. This is very important. The stabilities of alkenes have been related to their heats of hydrogenation. The hydrogenation of alkenes is an exothermic reaction. See here, heat of hydrogenation. The heat of hydrogenation is the quantity of heat evolved during hydrogenation of one molecule of alkene. Here, see pi bond, when pi bond is cleaved, it is 60 kilocalorie per mole energy will require. Hydrogen bond will cleave, it require 104 kilocalorie per mole energy. So total is 164 is required. Whereas due to the here new sigma bond is formed. See here, and one is evolving 97 kilocalorie per mole energy. So 97 multiplied with 2, it is 194. So it is a exothermic reaction. See here, 194 minus 164 is about 30 kilocalorie per mole energy. So it is a exothermic reaction. So due to this exothermic means heat evolved, heat of hydrogenation, so it is stability is also considered on the basis of the those molecules having less heat of hydrogenation, they are more stable. Means stability is inversely proportional to delta H value. We can compare this ethene molecule. Its delta H value is 32.8 kilocalorie per mole, whereas this propene molecule having 30.1 kilocalorie per mole. So difference is 2.7 kilocalorie per mole. So propene is more stable compared to ethene. This also we can explain on the basis of hyperconjugation. So due to the hyperconjugation resonating structure, it is more stable. Propene is more stable compared to ethene. Thus, the substitution of hydrogen atom of ethylene by methyl group lowers heat of hydrogenation and increase the stability. We can compare the stability order of this molecule. See here, ethene having 32.8, propene having 30.1, this isobutene having 28.4, whereas this molecule this ethene, tetramethylethene, or we can say 2,3-dimethyl 2-butene, it having 26.9. So which is more stable? This molecule is more stable. So fourth molecule is more stable compared to 3, compared to 2 and 1. Orientation of alkyl group. The trans isomer is more stable than the cis isomer, as there will be less steric hindrance and van der Waals strain in trans isomers. See here, this cis isomer having a higher delta H value 28.6, whereas trans isomer having 27.6. So trans isomer is more stable compared to cis isomer. So thank you very much for today's lecture.